Now let's look at the sign division. So far what we have discussed is for unsigned division. We constructed unsigned divider. How do we do the sign? Is the same thing as we did for the multiplication. If you understand that part, this is the same thing. We take the 2's complement of the dividend and divisor, make them basically both positive unsigned value depending on the sign of the divisor, and perform this unsigned division. Now, difference from the multiplier is that your multiplier output is 64-bit. It's a one output 64-bit. Divider outputs, it has two output, both are 32-bit. And we individually make 2's complement of remainder and quotient and pick up the correct signed value. So what is the correctness? Your quotient sign follows the same processing or same inference as we did for the multiplication. That is, if both operands, both dividend and divisor are positive or both are negative, then my quotient sign is positive. And if one of them, between dividend and divisor, one of them is negative, other is positive, quotient sign is negative. So that's what we did. We deploy the same XOR circuit connecting to the dividend 31-bit, 31st bit of dividend, MSB of the dividend and MSB of the divisor to determine the sign of the quotient and select that quotient accordingly, either its uncomplemented form or 2's complemented form. Now for the remainder, as I said, remainder has to be same sign as of dividend. So there is no XOR, we just, this dividend MSB acts as a selection circuit, selector of the multiplexer, selecting between uncomplemented value or the positive value or complemented value or the negative value bit pattern for the remainder. So that is the difference between our multiplication counterpart, where we need to deploy a 64-bit 2's complement calculations, and based on that we select it. Here we just rely on this 32-bit 2's complement circuit and picked up quotient with the same logic as we did in the multiplication, but remainder has to be same sign as of the dividend.